Hello everyone, welcome back to our YouTube channel Becoming a Rose Developer. I'm Desire and today we've got Diego who has just completed the course Python Basics for Robotics, and he'll be giving us a presentation of that. So without any further ado, let me now hand over the platform to him so that he can begin his presentation. Okay, Diego, whenever you're ready.
Okay, thank you. Hi everyone. Well, do you want me to present first the no class or the class version?
Let's see the non-class version and let's have it run on the real robot as you explained. So yeah, you can start execution and then you explain as you go.
Okay, excellent. Now I have here the bring up program for the real robot, and I'm going to run the Python script for the no class version. So I will get ready, 5 seconds, and it will execute every function that was asked in the project. So it's going to move forward, backward, turn left, right during a specific time. For example, here 1 second. Now it's going to move a distance to the front. Now to the back. Okay, the left and right targets they didn't reach the target. I'm going to restart the simulation. Well, the program. I'm just going to move the robot in here so that it has more space to operate. I noticed that this is like kind of glitch. It sometimes happens when the robot is very close to a wall or collisions into a wall. Okay, again. So the robot is now in an open space. Okay, moving forward, backward, left, right, for 1 second each. Now moving forward. It collision again. Well, let's see if it's moving. No. Again, it collision. My God.
Yeah.
Yeah, let me just turn it again more to the left. Okay. Hope this works. Okay, the same. Okay, now to the front. To the back. Okay. I think I'm having a problem here. I'm going to continue with the next functions and just try to fix later.
Okay.
But
all right.
actually, it's turning left, right. Then it's taking the minimum scan angles and different scan ranges. So for these scan ranges, I used a function to print all the scan angles from minus pi to pi.
Yes.
And all the scan ranges go from those ranges of angles. So using that information, I calculated the different front, back, left, and right scan ranges using functions that will determine the index depending on a comparison until they reach a specific angle.
Okay.
Also, the current position is gained by the odometry of the robot using the IMU, and I also have the distance traveled with the robot using it's similar to a math hypod, but I didn't use the function math hypod. I use arithmetics, and this is a script that performs every function described in the task. As you can see, the no class, it doesn't have any class in the script. So it uses the instance of the robot that is defined in here. And I just created functions that will access the robot methods using the attributes, for example, linear velocity, angular velocity, this while structure to make the robot move in a specific time.
Mm-hmm.
The turn, for example, this one of the distance, I'm using the current position of the robot in order to calculate the distance traveled using this get distance function. The get distance function will receive 4 parameters.
Mm-hmm.
That is the hypoth parameters. But for example, the distance function is in here. I will use arithmetics, the square root of these positions.
Ah, okay.
So with this, I tell the robot to move a specific distance. In the case of the angles, I don't know why it didn't work. It was working the last time I tested.
Yeah, it's understandable. Okay.
But in here, I didn't use, for example, the position in X and Y. I used the job to determine the angle in which it is, rotating.
Yes.
And also in here, in these functions, I, where it is? Okay, it is not exact, as you can see, for example, in here, the target is 0.20
Mm-hmm.
and the current was 0.22.
Right.
But because of the velocity of the robot, it is not exact. So there's a naive algorithm.
Yes.
And for the odometry, getter functions, all using the attributes of the instance that we created. For the minimum, maximum ranges, for example, without infinite, I use this not math is inf. That is telling if it is not infinite,
Mm-hmm.
just scan the ranges and get an index so we can get the ranges of those angles. And I tried them. That's what you saw in the program execution.
Mm-hmm. All right. So let's see the class division executing, and then you can run through it as the same way you did for this one.
Sorry, can you repeat, please?
You can now demonstrate the class division, and then you can also show it executing on the real robot. Yep.
Yes. So for this, I'm going to use the control. What's happening?
Just see it clear.
Oh my god. Let me just open a new terminal. Do it again.
Yeah.
Yeah, I know what happened. Okay. And this is the class. Okay. Now for the class script, it's going to perform 3 main functions in order to avoid obstacles, to detect if the obstacles are a wall, if it's a wall or an obstacle, and it will tell the orientation of the robot. So, for example, in here, it's going to the north-northwest orientation. It detects a wall, and it's going to move to the left in order to avoid the wall. Also, it's telling us the current angular velocity and linear acceleration. For example, it's a naive algorithm, so it sometimes detects an obstacle as a wall and a wall as an obstacle. Or I think it's pretty precise sometimes.
Yeah, it looks like it does well when avoiding obstacles, which is really good.
And that's the function of the class, the script.
All right. So show us the code, and then you can also explain what's going on there, how you managed to get that behavior out of it.
Of course. In here, I have let me just make it bigger. Okay. So for the class, we're working also with the robot interface. So we create an instance in the main function. But the difference is that we are making a class and passing this instance as an attribute of our. No, it is actually in here. We are passing this instance as an attribute of our class. So having this object in our class gives us permission to use all the methods of that class, that is robot interface.
Yeah. Okay, I see.
So I made all the functions that were in the no class script as classed functions using this self condition that tells the function that, hey, I am from the robot control class. So I gain access to all the methods and attributes of that robot interface class. So it's the same, using linear angular velocity for moving front, moving back, turn left, right. It's the same logic for time front, time back. Also for moving a specific distance. Also for getting the odometry, the laser scan, the minimum ranges, position, acceleration. And in here this is the difference from the other script. We have 3 different functions in order to control this robot in an autonomous way. The first one is the obstacle prediction. So what I did was to calculate dividing the circle of the scan ranges into different sections. In this case, 8 sections of 45 degrees.
Yes.
So I could get the front angle, left and right angle.
Yes.
Front left and front right. So using these values that I calculated, I calculated the index until it's in the front right and in the front left. And with that index, I appended the scan ranges into a new list of ranges. And those are my ranges from front left to front right.
Okay, so you have got a new data structure there. Okay, I see.
Then I calculate the minimum. And if it was more than the threshold, that is 3, well, the obstacle prediction is none. It's open space.
Okay.
But if not, it's going to use a multimode function in the rounded values of my list. I rounded it to 3 values, to 3 decimals, sorry. And the multimode function will return the number of modes that, the values that most repeated in that list. So if there is more than one value, the same value repeated more than one time,
yes,
it's going to be an obstacle.
Okay.
But if not, it's going to be a wall.
Yeah, I like that implementation. I like it a lot. Okay.
Thank you. Then it's the direction tracking, in which I did the same with the circle of the scan ranges, but divided in 16. So I gained 4 different sections between, for example, north and east, 4 different sections between east and south, just as the task asked us to implement.
Okay.
For example, if the current jaw of the robot is between one of those ranges, it's going to print the orientation of the robot.
Okay.
So that's what I did. In the case of S, for example, it has to AND conditions, because I took each 16 segments as the middle of the range. So each range is going to be defined as the middle of each segment, so we can, it's like a different approach of the segments I divided it.
Okay, so you're basically bisecting the angle into 2 halves, and then you take the one that is in the center.
Yes.
Okay, I see.
And the naive obstacle avoider. In here, I use the same logic, dividing the circle into 8 different pieces, segments, in order to get the front left, right, and front right range. So in here, I use these while and if conditions in order to get the index of each of these ranges. For example, in this case, for getting the right range, I compare the angle from the beginning until from this value that it's on the left until the next segment that is bigger. It's this one.
Okay.
And actually this is smaller. from this to this length, and that's gonna be the range of my right range list. So I append the ranges from that range,
Mm-hmm.
and I continue doing the same. So I get at the end the ranges the task is asking me to calculate,
Mm-hmm.
and I calculate the minimum from that ranges. So most of it's possible that some of the ranges have the infinite value.
Mm-hmm.
So in case of its value, well, I just mark it as a value, because the min function cannot differentiate if it's infinite or a float if you do not pass this parameter.
Mm-hmm. Yeah. This is
And
really a very good way of implementing obstacle avoidance. I think you did a very good job there, because we can still see on the left side of your screen there that the robot is still doing very well at avoiding obstacles. So well done on that bit.
thank you. And it's
Yeah.
thanks to this algorithm that decides
Yeah.
moving front, left, right,
Uh,
depending on which range it detects the minimum threshold.
yes, and from the way you're also explaining the implementation, it does show that you put a lot of thought into this, and also to make it effective, you had to do the computations right very well. So this is really good, and it's proof, because we can see that it's avoiding obstacles very nicely there.
Thank you.
All right, you can go on.
Yes, that's everything.
All right, very good. I really like this. Well done. All right, so I'm gonna ask you like some really basic things, but it would be very nice if you can show us some of the ways of implementing these things. So the first thing, since this is like a Python basics course, can you like show us in the act how you'd extract like values within a particular range in a list, right? So you can maybe be writing some pseudocode or the actual code below your script.
Okay, to extract values from a list.
Yeah, so let's say you have a list that you call L, and you want to extract like the first to the fifth value. How would you do it?
Okay. Well, I'm going to make another function in here so I can explain this.
Yeah, just a basic
For example,
one,
extraction. I'm going to create a list, L. For example, the elements these ones.
Yep.
And in order to extract, the function, in order to extract these elements, I have to use the index. So in here, the first index is 0. And I go from 0 to 1, 2, 3, 4, 5, etc. until it's finished.
Yes.
Now, in order to access these elements, I can use, for example, a for. A for function. For I variable in L. For example, extraction equals L E. I is my I is my index. And for example, I can print I. This is in order to get all the elements of my list.
All right. So now let's get.
If I only okay.
Yeah, go ahead.
Yes.
I like the way you're explaining. Yeah.
And yeah, that's the way in which I can get all the values in the list.
All right. So what if we say you cannot use a for loop, right? There should be another way, and clearly there is some other way of getting a range of values. So let's say you just want to pick the two in the middle, line 9 and 3, for example, right?
Okay.
Without using a for loop, yeah.
For example, extraction 1, I can say, equals L number 2, that is the third element. And extraction 2 equals L3, that is the fourth element.
Yeah, okay. That's also good. It does work. You can take them out like that and then you blend them. But the actual method I was looking for is where you'd say L and then you put a semicolon, a colon, and then you put like the last index. So in that case, it will be up to 3. So,
Okay.
yes.
This one.
But yeah, I think it just skipped you a bit, but you probably do know this method. So this is the one I was looking for, but it's quite good. You
Okay,
also
okay.
showed me that you could also do it the other way around, right? All good. This is just shorter. It makes it a lot more easier for you in terms of the amount
Okay,
of
okay.
typing you have to do. And I also did like the fact that you showed that in a list you can put any data type. It doesn't care, right? You put a string and then you put integers there. So very nice. It's good to know that you know these subtleties. The last thing I want to ask you is, what is the biggest difference between like a list and a dictionary? We use this quite a lot, so just give us like some theoretical
Okay.
background and underpinnings of those two.
The difference between, for example, a list, a tuple, and a dictionary is that the list you can modify it in like using, for example, L3 equals 6. And I'm modifying the fourth element of the list with number 6, with an element 6. The tuple that is used, for example, H, with using parentheses, it cannot be modified after.
Yes.
So if I use H3 equals 7, I cannot do that.
Okay, good.
And in a dictionary, for example, dictionary, like I use these like keys, and I use a key in order to identify the element I'm going to specify. For example, octopus.
Yes.
It equals 25.
Understood.
So
yeah.
in order to access the dictionary, I have to access through the key. So, for example, print dictionary octopus.
Yeah.
And it's going to tell, well, to gain the value of 25.
Nice. Very well done. Thank you so much, Diego. Thank you very much. Alright. So what we're going to do is we're going to wrap it up here. So I suggest you have it and then we'll finish our conversation here, okay? Alright everyone, this was Diego's presentation and a warm congratulations to him. Would like to encourage all those of you who would want to try this project to do so, and you can also give a shot to all the courses that we offer certification on our website, and you can come and showcase your work here. So until next time, we encourage you to keep pushing your Roche learning. Bye bye.